Hi, everybody, again. This is Mr. Polly, and let's do 9 through some more. Okay, so answer the questions that follow about propene. So propene and vinyl chloride, shown above. Identify the intermolecular forces present in each molecule. All C's and H's, so propene, only dispersion. And then chloroethane. This part right here is not carbon-hydrogen, so it has dipole-dipole. And everything has dispersion and dispersion. Okay, the boiling point of liquid propene is 226 Kelvin, is lower than the boiling point of vinyl chloride, 260. Count for this in terms of the types and strengths of intermolecular forces present in each liquid. So, propene has only weaker dispersion compared to dipole and dispersion in vinyl chloride. Stronger bonds, stronger intermolecular forces, clump more, and require a higher temperature to separate into, whoops, I put separatin, separate into gases, aka boil, All right, pentane, propane, methanol. So when I'm looking at these pictures right away, I'm thinking nonpolar. Nonpolar, why? Because it's got all C's and H's. And then I've got H bond. Here's an H bond, right? This is H bond and polar. This one is just polar. Remember, it's H bonded because it's H directly bonded to an O. Okay? It's the following question in terms of principles of chemical bonding and intermolecular forces. In each explanation where comparisons are made, complete answer must include discussion of both substances. The complete loose dialectic is shown in museful. So pentane is a liquid, whereas propane is a gas. So pentane is stronger. Pentane is a liquid, while propane is a gas. They're both nonpolar. So pentane has a larger electron cloud than propane. So it is more polarizable, and it takes more energy to change from liquid to gas. Okay. Methanol is a liquid, whereas propane is a gas. Okay, so this one we're not going to talk about the size of the electron cloud because it's smaller. What we're going to talk about is those forces. So methanol has strong H bonds, and propane does not. So, whoops, it, take it out here, takes more energy to turn, I put turn with a TO, turn CH3OH into gas. So it is a, let's see if I can change my color here. Ooh, look at that. Two types of intermolecular forces present in liquid H2S are London dispersion forces and dipole-dipole forces. Compare the strength of the London dispersion forces in liquid H2O to the strength of London dispersion force of H2O. Explain. H2S has 18 electrons. H2O has 10 electrons. So when I look at the periodic table, S has 16, each hydrogen has 1, each oxygen has 8, so periodic table goes from there. And remember, more electrons equals stronger dispersion. For the strength of dipole force in H2S to H2O. Okay, so H to S and H to O. I'm going to look at the periodic table. So O is here, S is here. No, you're okay. So for this, so H is over here, right? So remember, H to O is more polar. So H to O is more polar. And looking at Coulomb's law, Q1, Q2 over radius squared, more polar equals bigger, Q equals stronger per Coulomb. Compare the strength of dipole forces of this. So H2O, just to make it clear, H2O's forces are greater than H2S. I put H2O is greater than H2O. That's not so good. H2S. All right, consider bromine and chlorine. What intermolecular forces do they both exhibit? Okay, so they are nonpolar because bonded to itself. So what intermolecular forces do you exhibit if you're only nonpolar? That would be dispersion only. Because nonpolar bonds make nonpolar molecules. And then remember, nonpolar molecules can only make dispersion forces. Which has stronger intermolecular forces? So I'm doing a tiebreaker, right? So I'm doing a tiebreaker. The one that's bigger wins. So I'm looking for a periodic table in my neighborhood again. I found one. All right, so I'm looking at bromine and chlorine. So bromine is larger with more electrons. So its cloud is more polarizable and has stronger IM. Whoa, that doesn't even look like IMFs. IMFs. Good. Let me go to a little blue. What do you expect to be liquid at room temperature? Ooh. Well, I would expect it to be bromine because it's blue and Br2 because it has stronger forces. And Cl2 is a gas. I hope you know Cl2 is a gas. I talk about being one of the poison gases in World War I. So, gas because it is weak. I need to start writing slower. This is because it's good. Consider this dude right here, illustrated with an X in place of a halogen. What intermolecular forces are present in all haloacidic gases? See this guy right here? That is an H bond. See this guy right here? That is dipole-dipole. See this right here? Dipole-dipole. Now why? The reason why is because anytime you have polar molecules, you get dipole-dipole interactions. Okay? Because one end's positive, the other end's negative. Okay? So there's my answers up there. All right, which haloacidic acid would you expect to have the highest boiling point? Chlorine, bromine, or iodine? So they're all going to be the same. So the one that's going to be the most polar is my first thought. Because it's a polar bond, it's going to be the one that's most polar. So that means the most polar one is going to be the one that is most electronegative. Now I'm thinking closer to fluorine, and really it's because it's smaller and more attractive. And that would be Cl. Oh, and I just explained my reasoning. It's the most polar, most electronegative, makes strongest bond energy in Q1, Q2 over radius squared. So it's the most polar, it's the most electronegative, which means my Q's are the biggest. That's a fun question about the isomers of ethanol and dimethyl ether. Oh, so I have hydrogen bonding here. And I don't have hydrogen bonding here. I only have a hidden polar. Okay. Why are they isomers of each other? An isomer, remember, is same atoms with a different arrangement. Identify all intermolecular forces in both molecules. So for ethanol, it has H bonds and dispersion. So ethanol has hydrogen bonds and dispersion forces. And then dimethyl has, as we said before, dipole-dipole. And it's barely dipole-dipole because, man, is that hidden. And dispersion. The reason why I say it's barely and it's hidden in there, do you see how this kind of blocks out the polarity of it? So that's just, no, that's probably the weakest. It is the weakest kind of polar you can have, is one buried in the middle. Ethanol has a boiling point of 78, so ethanol is 78. So remember, ethanol is strong. F is strong. Oh, I'm going to slow down my writing. F is strong. 78. Ethanol is strong and has 78-degree boiling point. And dimethyl ether is negative 24, so that's weaker. Identify the molecular force that's intermolecular force that's most responsible. So the difference for this is H bond is stronger than dipole-dipole. Because they are isomers, I wouldn't talk about the difference between their electron cloud because they have the same number of electrons. All right, nonane 2,3,4 trifluoropentane. Shown above are the Lewis structures for nonane and 2,3,4 trifluoropentane. By the way, I'm already talking about this being nonpolar, and that's going to be dispersion only. And this one has all this stuff right here. So it's got dipole, 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 dipole. Identify the intermolecular forces present in both. So nonane, dispersion only. And then 2, 3, 4, that whatever that long name is dipole, dipole, and dispersion. Don't ever forget dispersion. Dispersion's always there for you. Nonane has a higher boiling point than 2,3,4 difluoropentane, even though they have nearly identical molar masses. Which intermolecular force responsible for this difference? So they have nearly identical molar masses, but so what this says is dispersion is greater than dipole-dipole. Oh my goodness, it tells me, and you're like, what the, what? Okay, so remember how we talked about dispersion can be a lot more? So they have nearly identical molar masses, which means they have nearly identical number of electrons. So what that means is, and this is where it sneaks in there, stronger intermolecular forces, or I'll do dispersion forces since I put M. Stronger dispersion in nonane because a larger surface area. is more polarizable. Now here they're talking about surface area. I really like to say, instead of surface area, electron cloud, and both of those would get you full credit. Okay. Explain how the intermolecular forces in 15Bi cause the difference in boiling point. Boiling point increases with stronger forces. Oops, I'm going to rewrite the word forces because I'm writing too fast. With stronger forces. Okay. No name has stronger dispersion than 2,3/4 dispersion and dipole. All right, looking at some new structures. Shown above are the Lewis structure of propranoic and butanoic acid. So I'm looking at this. They both have H and dipole, H bonding and dipole. And then I'm going to notice right away this one's bigger. So this is going to be a bigger one, so it's going to have more dispersion. Okay. So propanoic has a lower BP, and this has a higher BP. BP is boiling point. Identify all intermolecular forces present in each. Oh, man. So we have H bonding, dipole, and dispersion in both. Which intermolecular force is most responsible for the difference in boiling point? Dispersion, because butanoic has more electrons and it is more polarizable. Man, I love that word because when I say it, I know I got a punto. Br2 has a higher boiling point than BrCl2. Ooh, Br2? That's nonpolar. So Br to Br is nonpolar because it's bonded to itself, and it has only dispersion forces. Br to Cl would be polar. Yep. So it's going to be dipole because it's not the same. Dipole. But then it says this one has, so Br2 has a higher boiling point. So it says Br2 is stronger. Remember, if you have a higher boiling point, that makes you go, what the what? So whenever that happens, that means that Br2 has a larger electron cloud, and 2 bromines would be 70 compared to whoops, oh my goodness gracious, St. Ignatius. Bum, bum, bum. Compared to BrCl, which is 17 plus 35, that's 45, that's 52. So Br2 is, yep, you guessed it, more polarizable and more attractive. Okay, change my color again. Oh, how about a little green? Energy is required to boil ethanol. Consider the statement: as ethanol boils, energy goes into breaking the CC bonds, CH bonds, CO bonds, and OH bonds. Is this statement true or false? Justify your answer. It is false. Although that word does not look like false. False. Covalent. I'm going to go back to a different color. Maybe black will write better. Covalent bonds are not broken when covalent compounds boil. Okay, so if I have ethanol, so I'm just going to write it as C8. Well, ethanol is up here, isn't it? No. Ethanol is C2H5OH. Okay, C2H5OH. Boiling means another C2H5OH leaves, right? That's what boiling is. So what breaks is the intermolecular force. So H bonding breaks. All right, here we go. Another page bites the dust. Shown above are 4 identical flasks contains different liquids all at the same temperature. Hey, I see this as vapor pressure, right? So this one has the most dots. This is the weakest. And I know that because it had the most dots. This one is the strongest. It has the fewest dots. And remember, those dots would be gas particles. All at the same temperature. The particles above each liquid are in the vapor phase. Which flask has the weakest force of attraction between the particles? Explain your reasoning. B, because weak bonds allow, liquid to turn to gas easily. Which flask has the strongest forces? Explain your reasoning. C, because strong forces. Remember, I like the word clump. Clump and stay liquid the most. Oh, and I should also say fewest dots. And for this one, I should say most dots. While the particles were nonpolar, what could be a possible reason for the difference in the strength of intermolecular forces? So remember, we do the difference in strength. I could have hydrogen bonding or dipole-dipole or dispersion. Or I can just say different electron cloud sizes give different intermolecular forces. Or some are H bond dipoles of different strength. Yeah. Oh, wait a minute. I just realized I just now read this. This part right here is wrong because it says they're all nonpolar. Okay? If all the particles were polar but did not contain hydrogen bonding, what intermolecular force would contribute to the differences in strength? It's the exact same answer. Different electron cloud sizes give different intermolecular forces. I suppose I should add in both spots. Bigger clouds mean less evaporation. Bigger clouds equals less evap. Bigger clouds equals less evap. Would the particle in flask A have more or fewer the same number of electrons than the particle in flask D? So A versus D. So A has fewer dots, so stronger forces, so larger electron cloud. I got a lot of so's in here. So more electrons. Good. Man. Consider the 3 gases above in 3 identical containers, kind of like what we saw before. As the pressure of the gases increased as the pressure of the gases is increased, they transition from gas phase to liquid phase. Okay, explain at a molecular level why increasing the pressure of the gas would change it from a gas to a liquid. Why would increase the pressure? Particles collide and may stick and form liquids with the collision. If you bump into somebody, you might become friends, right? Which gas would condense with the least amount of pressure? Explain your reason. So condense with the least amount of pressure, that means it's going to be the most attractive. The most attractive would condense first. The most attractive would be, notice how these are all C's and H's, they're all dispersion, right? So this one has the biggest cloud. So C4H10 has the biggest electron cloud and is the most attractive. So it condenses first. And it has the biggest electron cloud because look, it's got 4 carbons and 10 hydrogens, which is more than the other one. All right, almost there. Use the figure above to answer questions following. What does arrow A indicate? A covalent bond between H and O. Well, not H, yeah, H and O. Okay, so notice that's a covalent bond. That is not hydrogen bonding. Arrow D indicates a hydrogen bond. Explain why D indicates a hydrogen bond while B and C do not. An H bond is an H directly bonded